probably the most important. Hopefully you'll learn a few things and hopefully agree with me. So, what is the glory of God? First of all, I thought about that, and I figured first thing I would do is maybe get a definition of it. And I've got a definition from the Oxford Living Dictionary. It says, number one, high renown or honor won by notable achievements. It's kind of like the definition I prefer. The next one is magnificence or great beauty, often glories, the thing that is beautiful, impressive, or worthy of praise, the splendor and bliss of heaven. Third one is praise, worship, and thanksgiving offered to a deity. Luminous ring or halo, especially as depicted around the head of Christ or a saint. I thought about the first verse of it, and I thought about that, and I said, we call our flag, "Oh Glory," right? It's not that the flag has glory, it's the meaning behind the flag, the accomplishments and what our country means, and that's why I believe it's called glory. And I kind of like that, and I'm tying that into where God is. So, the next definition I found in the Baker's Evangelical Dictionary of Biblical Theology. It says, the most significant use of the ideas of glory and majesty is their application to God. In this regard, it is sometimes stated that God's glory is the external manifestation of his being. God's glory is something that appears, it is revealed, or can be seen. There is also a more fundamental sense in which God has glory prior to any external manifestation of it. And I think that's possibly due because we recognize God's crowning achievement, and that is actually our creation. Think about that. What God has done proves that there is a God. In addition, David Hutter writes, in addition to referring to the actual glory of God, the words sometimes refer to the recognition of his glory. This is, of course, true whenever we read of giving glory to God or of glorifying him. We do not add to his glory. I like that. We do not add to his glory. We merely recognize and acknowledge it. When you think about God and think about his creation, we recognize what God has done, and we happily give him the glory for what he's done. In a number of passages, it is also difficult to know whether God's glory refers to his actual glory or to human recognition of it. This is true, for example, when Scripture speaks of the earth being full of the glory of the Lord. And this recognition of what God's accomplishments are is where I'm going to go with, especially when we start talking about bees. I want to expand on that. For example, as a person examines his environment, he will realize that there is something greater than the sum total of all that he perceives. And it is and what is necessary to create all these things. This uncaused first cause can be appropriately called God and deserving praise and worship, thus recognizing God and giving him glory. I tend to liken this to the fingerprints of God. Think about that. When you think about a fingerprint, what is it? Webster defines a fingerprint as something that identifies, such as a trait, trace, or characteristic revealing origin or responsibility. Obviously, detectives, when they're going to a scene of a crime, they will go out and take fingerprints so they can identify who was the culprit of doing that thing. So when we look at things in our environment that have complexity and point to a creator, to me that's aptly called the fingerprints of God. The Bible says in Revelation 4:11, Mark used this last week, and I thought it was good to add it again today. It says in chapter 4, verse 11, "You are worthy, our Lord and God, to receive glory and honor and power, for you created all things, and by your will they were created and have their being." Think about that. He deserves and when we recognize his creation, he deserves the glory and praise and honor that we aptly should give to God. In Psalm 19, verses 1 and 2, the heavens declare the glory of God. The skies proclaim the work of his hands. Day after day, they pour forth speech. Night after night, they reveal knowledge. So think about that. As you look up into the sky, the psalmist David says, man, boy, what is that? That actually tells me that there's something out there, a creator. And that actually tells us to give him the glory. As I read these passages, it appears to me that the Lord is telling us that one uses his God-given intellect and reason and examines and studies the firmament and the natural world, it should naturally point towards the supernatural, namely God, its creator. As an apologist, I love to continually find examples that can point the unchurched to Christ. And for me, I found the one area that points me to God, it's where I see the fingerprints of God, and it is something that I have a passion for. I love and I work with honeybees, and there I am. As you can see, I look good in my suit, don't I? That's a frame of honey that we pulled out, I think it was a year or two, and just that's one of the nice things about honeybees, besides pollination, and they give us one of the neatest foods in the world, and that is honey. So a little history about me. First of all, sometimes I wonder if I keep bees or they keep me. I don't know. I know it's a beneficial relationship for both of us. I give them a home and some food and medications and nurture and give them the things they require. And I receive honey, obviously, one of nature's most perfect sweeteners. I get a little income out of it and a tremendous joy and satisfaction in watching my bees work and grow and propagate. Before I get started, I know most people find out I raise bees, they look at me like I'm quite peculiar, and that's a fact that I don't doubt. And they invariably want to ask me the same question, and I'm going to answer it right now. Before we start, I know you're itching to ask, do I get bit often? And I want to tell you right now, I've never been bitten by a bee. Never. And I don't plan to get bitten by a bee. But I have been stung a couple thousand times. so, bees don't bite, they sting. And actually, when a bee is a female bee, when she stings, she actually has her stinger pulled out and she'll crawl off and die. So she doesn't want to do that. She's doing that only in reference to the fact she thinks her home is being threatened, her hive or colony is being threatened, or her life is being threatened. So that's why honeybees will do that. So they don't really want to sting. And generally, they're relatively calm insects. Now, as I study the honeybee colony, I start to comprehend the complexity of this life cycle, and it literally does amaze me. It directs me to ask those difficult questions. For example, how could this insect evolve into such a complex life cycle under the natural processes of time, mutations, chance, and the survival of the fittest? It's one thing to say that species evolved from one to another, but shouldn't we ask and expect answers from the evolutionists out there who says it happened without any proof? Think about that, And so, in 1859, Mr. Charles Darwin wrote, "If it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down." Do you see that? Even Charles Darwin was giving an out, saying if you can't prove that it happens, then maybe my theory of macroevolution is wrong. Now, we believe in microevolution. In fact, he observed that whenever he was out on the island that year, and he was seeing sparrows due to the difference in the weather. They were changing from a very, very large, hard beak to a smaller beak, depending on how hard the seed coats were. That is because in any general population of a species, we have variability, and we can change to a different variability, a different phenotype, depending on what those variabilities are. So we see microevolution happen all the time. How many of us have a Chihuahua? How many of us has a collie? Who has that? You go down, that's a variability that's within one species, and that's canine. We can see that. But we don't see dogs changing to elephants, do we? So think about that. We don't have a change in species, we have a change in the phenotype of that species. So, noted intelligent designer Michael Behe's criticisms of Darwin are simple. He states, even a simple slight modification in a structure or metabolic pathway may require a complex amount of changes, especially of the genetic code and what you see in that organism. It may appear simple to us, particularly in Darwin's day when they didn't know, they weren't able to get into the microstructures that are in the cell, but it in reality is very, 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 very complex. And he lists some of the examples that you see. For example, the eye is very complex. And how did it evolve? Slowly over thousands and thousands of generations. Blood clotting in human beings is kind of interesting because the same in blood clotting, you have a factor that actually keeps the blood flowing in your arteries and veins, but at the moment you cut yourself, then it actually stops the blood. So how did that, the hundreds of different pathways that you have to have blood clotting in the human body is amazing. But how did that happen to evolve slowly over thousands of years, or thousands of generations? People will say it happened, but they won't give you the hows of how it happened. So, and he looks at that. He even talks about a single-celled bacterial motor. It's, as you can see a sample of this actually looks like a motor in here. It actually has a shaft, it has a pulley, which is actually the flagellum, it has bearings on it, and it has a stator, which actually can move. That flagellum, from what I understand, can give you like 1,000 movements, that spins in a second. And it can stop on a dime and reverse. Now, this is a single-celled bacteria, which isn't actually a true cell. This is one of the simplest forms of life, but yet it's irreducibly complex. He uses a mouse trap. How many of us has a little wooden mouse trap at home catching those little beasties? Well, if you look at it, it is irreducibly complex. It's down, if you miss just one part out of that mouse trap, say a staple, and when you try to set that, it'll fall apart. You need to have all those pieces together, that little piece of wood. You need to have the trap mechanism. You need to have the place where you put your peanut butter or bacon on there to attract the mice. You have all that stuff together. If you're missing one part, it won't work. So how do you get slight modifications over thousands of generations, slowly building that mousetrap to be a successful unit to be able to catch mice? Because in the time period while you're waiting for those structures to come together, that species, that insect or whatever is going to die because it can't feed itself. So he calls this the irreducible complexity of it. From purely an evolutionary standpoint, a non-functioning structure would be a detriment to that species and would eventually disappear as an extinct species. So while you're waiting for those modifications to come together to make that efficient, it would actually die because it isn't efficient over thousands of generations. So there are a few things that I find interesting, and I can't believe that evolution can answer and rationally account for the development of the modern honeybee. An evolutionist will adamantly state that a species simply evolves slowly over long periods of time, but they can't tell us how and produce any of the missing links that you need. When talking with a macroevolutionist, I want to ask them the questions. In fact, if Mr. Darwin would come in right now, I would ask these questions about the honeybee and say, how? And show me the proof. So first and foremost, we'll go to the next slide. Bees are a social insect. Honeybees a single bee cannot go out and start a new colony. That's quite interesting. You need probably 3,000 to 5,000 bees come together. You'll need a queen and some workers and maybe a few drones to come together to be able to start a colony. And that's if I'm there, a beekeeper's there to be able to feed them and to nurture them along. So I would like to know, how do these three different castes evolve? The first one, we got a little picture of the caste of bees. Those are the three different bees that we have in the honeybee colony. Now, the one on the left is the worker bee. That's an unfertilized female. They're probably anywhere from, and through the winter, you may end up with 10 or 15,000 of them in a colony, and they will build up to about 50,000 bees in the middle of summer. They do all the work. When a honeybee worker is born, she will actually go, the first thing she does is clean the cell that she comes out of. And then she does different work things. She'll start feeding the larva, the mature larva in the hive, then the small larva in the hive. They'll defend the hive. They'll clean the hive. They will process the nectar and make it into honey. They have great duties within the honeybee hive. So they're really, really needed. The middle one is the drone. It's quite interesting. The drone is the male bee in the hive. There's normally anywhere from 300 to 400 of them in a strong colony. The interesting thing about a male bee is it's actually the product of an unfertilized egg. It has half of the chromosome number in the female bees. I'm not sure how that works. There are a few other species that have that, but when the queen lays an unfertilized egg, it will turn into a male bee. And his job basically is just to sit around the hive, kind of like mine is. I don't do much around the house too, my wife will tell you. But just to sit around the hive, eat a little bit of food, and his job is to mate with the virgin queens. He is necessary to mate with the queens. When the queen hatches, she comes out within a week or so, she'll go out and fly. And she'll go to drone congregation areas, and she will mate with the males. Now, this is what's scary if you're a male bee. Whenever you do mate with the queen, yay, you're mating, but guess what? She actually removes the seminal vessels of the drone, and it has an audible pop, they say, and he falls to the ground and dies. So it's not a great job. So if you don't want to die mating with the queen in October or so, they will actually kick you out of the hive because you're useless throughout the winter. So it's not a great job being a male bee, from what I understand. So now the last one, as you can see, the little bit bigger bee. You want to go back a little bit there? That's the queen bee. She is a female bee also. She starts with a fertilized egg. Now the difference between her and the worker bee is quite interesting. It is how they are fed and the size of the cell that the bees build around her. Now we can go to the next slide. In there you can see one of my honeybee queens, if you can. I think she's got a red dot on her. I can barely see it here, but around her is a little bit of a pseudo-court. The worker bees will go around the queen and they will smell her. It's called her pheromone. And whenever they can smell the queen, they say, hey, everything's right in the hive. It's a good day. And they actually smell with their antennas. And as they walk through the hive, they will actually let the other bees know the queen's okay. She's on her throne. She's laying eggs. So the next one, if you want to see, we got a picture. Those big fat bees in the middle are a couple of my drones that we took earlier this spring. But the queen bee, it's quite interesting. They all start out as a fertilized egg, so it's going to turn into a female. The egg hatches at 3 days, and then it's fed royal jelly. And any of you ever heard of royal jelly? Royal jelly is a secretion from some glands on the head of a worker bee. It's very nutritious, and they feed every larva at least 3 days of royal jelly. At the end of 3 days, if you start mixing bee bread, which is pollen and nectar or honey, and feed that to the larva, it turns into a worker bee. But if you need a queen bee, what they'll do is they continue feeding it just royal jelly. They increase the size of the cell, and they'll actually make the cell come out, and they'll drop it straight up and down as opposed to coming out from the comb. And by feeding it royal jelly, it grows quicker. By giving it the larger cell, it turns into a queen bee. Now the queen bee, she does absolutely nothing but mate and lay eggs. She can't start a colony. And then when we're talking about the social insect, a queen bee can't go out and start another colony of bees. She has to go out with 2, 3, 4, 5,000 other bees to start a new colony. So how do they reproduce? Well, God has the answer. Next picture. This is a swarm. And what happens is the colony normally will prepare to start a new colony, and they will put queen cells in the hive, and they will start producing queen cells. And once the queen cells are about ready to hatch, the old queen and anywhere from 15, 20, 30, 40% of the worker bees in that hive will actually abscond and leave. They'll cluster normally around 50 feet or so from the colony. So if you see this, don't worry about it. Normally they don't sting. And while they're in that swarm, the worker bees will go out and they'll try to find a new location. Somebody's mailbox, or I've heard of them. They'll actually start a colony in a charcoal grill under a cover and stuff like that. They'll try to find a location where a new colony could be started. And then that colony, as that swarm will leave, and they will start building that new colony in that new location. Normally it ends up about a mile or two away. They don't want to be too close to one another to where they can't get enough food, the parent colony and that colony. But that's how they reproduce. Okay, Mr. Darwin, if you're here, tell me why they started doing that behavior and how they started to learn that behavior. Think about that. So, and back in the old colony, one of the queens will hatch. If if the other queens are lucky, they'll actually leave one queen, a couple other queens hatch, and they'll actually have some after swarms. But normally, the queen, whenever she hatches, her first duty is to go over there and kill the rest of the queen cells, and she'll take over the duty. She's a virgin. She'll go out and mate with those 30 or 40 drones over a period of a week, and within another week or so, she'll start laying eggs. Again, the queen, it's kind of interesting. She can lay a fertilized egg or an unfertilized egg at will, one sperm at a time. And she'll store that sperm whenever she mates for anywhere from 2 to 3 years. Now, the age of the bees are, the queen will last 2 to 3 years. Drones will last up until summer, end of summer. Worker bees are anywhere from 6 weeks in the summertime. They literally work themselves to death. Or through the winter time, they may live 5 to 6 months. And just to remember that when we get into some other aspects of what I look at, the aspects of honeybees and the complexity inside that hive. Okay, let's see, next page. Okay, I would just want to also mention the queens and the workers are both females. Any female egg, any fertilized egg could turn into a female. But none of them are considered perfect. Well, what I mean by that, if you look at the evolutionists will say that the bees evolved from a solitary ancestor that was by itself. So it had to feed and build a nest and develop that into a large colony and make new individuals that will continue going on. Wasps and hornets do something like that. In the fall, they will actually make a fertilized queens, and what they do, the queens will go and try to hide somewhere in your attic, under leaf litter, or whatever, and in the spring they will come out, and that queen will actually make a little bit of a paper cell, and they will put an egg in there, and she'll tend that until it hatches, and then the daughter and her, they'll continue, and they'll build a bigger nest, and about this time of year, they get to be a big problem because we touch them and we get stung like crazy. So, but the honeybee can't do that. The queen cannot, or any bee cannot start a new colony. I got interested in bees when I was a kid, and I used to go out with a jar and grab a few bees off a flower and say, "Mom, I'm starting my honeybee colony." That would never work. You have to have, again, like I said, a laying queen and 2, 3, 4,000 individuals to be able to start that colony off and have enough time before winter comes so they could store enough honey and nectar to be able to make the winter. Okay, the next thing is communication. No, bees don't have PowerPoint presentation and microphones, but they communicate. It's kind of interesting if a worker goes out and finds a field of clover, a ton of nectar. What she does, she comes back to her hive. When she comes back to the hive, she actually does a bee dance. In the darkness and in the confines of the hive, where it's completely dark, she will start doing a dance. And that dance communicates the location of that nectar source. And if it's too close, if it's a close one, it normally uses the round dance from what I understand. And if it's a farther away, they would do a little figure 8 dance. And they do this, the axis of the dance is actually in relationship, the food source, and the angle it is away from the sun. So if the sun's at 90 degrees and the food source is at 30 degrees, it will do a dance. The axis will be 30 degrees from what the sun is at that particular time. Then she will go, after she's done doing that dance, she'll empty her honey stomach into a cell, and the house bees will take care of that and actually evaporate that nectar from about 85% moisture down to about 17% to store it. And then she'll go back. She doesn't lead the bees to that nectar source. By that time, there's literally thousands of bees have left the hive, and they've gone and found that nectar source on their own. So how does communication like that in the insect evolve naturally over a long period of time? So the next one will show what those dances look like, the round dance and what we call the figure 8 or waggle dance. Now, waggle dance, she'll go up like this, and she'll come back up along that axis, and it makes it a little figure 8. So I just want to know how does communication in the beehive happen? I'm not aware of any other insect that does that. Most of the other insects, when they find a food source, an ant will leave a pheromone trail back, and they'll follow that back and forth. So it's kind of interesting. Next, we talked about the royal jelly glands. These are actually two queen cells, and you can see how the queen larva is actually floating in that sea of royal jelly. All bee larvae need royal jelly. But how did those glands evolve slowly over thousands of years? Was there a time then bee larvae didn't have royal jelly? Let me know. I want to know that. If you can't give me an answer, then I'm going to just say, hey, it points to a creator. The difference between, as I said earlier, between a queen and a worker is the amount of royal jelly and the amount of time that is fed royal jelly. So I want to ask, how did these structures evolve? And how did the worker instinctively know that all of a sudden these secretions were coming from their head, that it was a good feed source to be able to feed to the larva in the honeybee hive? You remember that worker, a worker is about, 5/8 of an inch? It's got a brain smaller than a pin of a head, and it only lives 6 weeks. How did it educate itself to know that royal jelly is going to be a food source in that hive? That's what people want to know. At least that's what I want to know. So, and, it's the old adage. We talk about which came first, the chicken or the egg. But I want to know which came first: the worker bee with royal jellies and the knowledge to be able to use that, or the royal jelly gland, or the royal jelly which is needed to produce that worker. It's kind of interesting dichotomy there. So, next, wax glands. Honeybees are probably the only insect that I'm aware of that actually manufactures their building material. I mentioned hornets and wasps earlier. They actually collect bits and pieces of cellulose, wood fiber, and they take and they chew that up and they make a paper nest. Where honeybees actually have 8 glands on the worker's abdomen, as you can see them. And they take that, and they'll take those little flecks of wax, and they will chew it, and they will make that interesting little honeycomb that we see over there. And the top left corner of that honeycomb, you'll see they actually have nectar stored in there. And down on the right lower corner of that picture, you can see that's actually brood. Those are the eggs. The honeybee is a perfect insect. And what I mean by that, the life cycle, it starts out as an egg, then becomes a larva, goes through a pupation period, and then hatches as a complete adult. It's a perfect insect. They do that within the confines of the honeycomb that's within the honeybee hive. So they construct that comb to be not only for storage, but also for a nursery to rear their brood. Next page. But look how complex this is. Now again, we got a bee that has a head, the brain smaller than a pin of a needle, but yet, the head of a needle, but it figured out that a hexagonal shape is the strongest shape that you can have that uses the least amount of material and will have the best integrity or strength. And look at that slide to the left. They actually build their comb on a 17-degree angle. Because if they build it straight out, when they put the nectar in there, which is 85 to 90% moisture, it would run out. So they were smart enough to be able to figure out to do that 17-degree angle, and they could put the nectar in there, and as it evaporates, eventually it will be very, very thick, just like honey is, and then they can cap it and store it. Now, the interesting thing, if you look at the bottom, that little apex at the bottom, it starts on the cell wall on the other side. That little zigzag rib down the middle is a very, very complex structure, and it actually increases the stability and the strength within the honey comb. So my questions again are, where did they get the knowledge and how they get the knowledge? First and foremost, whenever they started producing these wax flecks, not to just throw them away, but say, hey, I can build honeycomb from there and we can lay the eggs in here. Tell me how that evolved. It's kind of an interesting thing. So, okay, the next slide is the lack of vestigial organs. Anybody know what vestigial organs are? Our appendix is one. They claim it's an organ that we had back in our evolutionary ancestors that are no longer needed or used at any particular time. Now, again, my question is, I've never found any information that has shown that you'll find any of these organs on either the queen or the worker. My assumption is, if you have an ancestor, a solitary ancestor that was able to feed all the bees and start from one individual be able to build a new colony, then it would have to be able to make the wax, create the honeycomb, and also have the royal jelly glands in their forehead to do that. Well, the queen has none of those. So, and the worker doesn't have any of the organs to show how they could store sperm to be able to fertilize eggs. So since you don't have those organs, I fail to see how they could have evolved from a solitary insect up to this complex social insect. Kind of interesting. So, divergent. This is the next one. This is divergent evolutionary trees. Honeybees collect nectar and pollen, make it into honey, and store the pollen to feed their colony. And flowers need honeybees to collect the nectar and pollen so they can cross-pollinate, produce fruit, to produce seeds, to create the next generation of plants. Now think about that. Again, we're talking about a honeybee that may only live 6 weeks. How does it know by pollinating an apple tree flower, and it alone will be able to produce an apple with seeds that may produce an apple tree 15 years down the line to be able to feed the honeybee colony? It doesn't know that. So my question is how do these divergent paths from plants and animals evolve to be interdependent on one another? And actually, apple trees, there are, besides honeybees and bumblebees and a few other things, they cannot pollinate themselves at all. Plants change from wind pollination, the pollen being distributed by wind currents, to needing insects to do that. And in fact, the nectaries, the sugar that's within the flower of say, an apple tree, it is not necessary for the apple tree at all. The only reason it evolved is because it needed to attract a pollinating insect there to be able to pollinate the apple flower. Kind of interesting. So, next I have, again, nectar and pollen gathering. Not only the interesting thing about the honeybee is, if you're talking about survival of the fittest, Darwin tells us the survival of the fittest. When the honeybee goes out in April, it starts pollinating apple trees, and a wind gust comes over and blows it down onto a dandelion flower. It flies back to the apple tree and continues pollinating apple trees. Now, if you're talking about survival of the fittest, it would collect whatever pollen source it has right in front of it. At least I would think that. How could that insect know that it has to continue pollinating only the one species of flower to be able to create that new generation of plants for it? It's not a benefit to the honeybee not to be able to collect whatever nectar or whatever pollen it sees right in front of its face. Think about that. So how did it get the knowledge to only pollinate apple blossoms and not just take all the pollen out of a single flower? It's beyond understanding. Like I said, by limiting foraging activities to a single species at a time, it only benefits the flowering plant and not the honeybee. Think about that. It's just amazing. And lastly, the storage of nectar and pollen. How did this evolve? How did the honeybee know that it could take nectar, that if you leave nectar at room temperature for a couple hours or a couple weeks, it's going to spoil? But it finally came to the understanding that they could evaporate it to make honey. And again, it goes from 85 to 90% moisture down to between 16 and 18% moisture. And it's kind of interesting. Honey is a very stable product. Whenever you do that, honey will not spoil. Even if there are bacterial spores in the honey, it will not germinate because there's not enough moisture in there. It becomes a very, very, very stable product. So how do they learn that behavior to store that for times when they cannot collect nectar or bring pollen into the hive? It's a behavior that, again, instinctively they have it, but how did they learn that behavior? That's what I want. Because actually, my honeybee colonies, they only produce honey from about May through September. The end of September, maybe early October. We get 3, maybe 4 months where bees were actually producing enough honey to store, and we actually get that surplus crop. The rest of the time, they need that honey and pollen in the hive to be able to raise brood and to keep themselves going. Bees are kind of an interesting insect. We talked about evaporating nectar. During a honey flow in the middle of summer, you can actually put your hands in front of the hive at night, and you can feel the air coming out of the colony. They will actually set up a behavior where they'll bring air in from the outside through the whole colony and bring it out through the middle of the entrance, and you'll actually feel wind blowing. And that actually evaporates the moisture out of that honey and be able to that nectar to be able to make honey. It's kind of an interesting process. Again, how do they learn that? I just want to know that. I wish an evolutionist would be able to tell me how those behaviors could evolve naturally over slow periods. So anyway, to kind of conclude this, each one of these attributes creates a tremendous amount of complexity, particularly even at the microbiological level. For example, there are 9 genes necessary for the production of royal jelly, let alone the genes that are needed to manufacture or develop those structures within the head of the insect while it's developing. So it's a very, very complex structure, that even though when we look at it from our viewpoint, it looks like a simple structure. There's simply too much complexity in the bee's life cycle for slow, slight change over a tremendous amount of time. I believe Darwin himself, if you go back to his preposition initially, would actually say that his theory may not be valid. Slow modifications over a long period of time do not answer how honeybees have the complexity within that hive. So, as I like to say, I've said it for years, it simply is this. When one looks into the honeybee colony, you can find the fingerprints of God. Robert Jastrow, he says in his book, The God and the Astronomers. This was written about 12, 15 years ago. And at this time, I believe this gentleman was an agnostic. And listen to what he says. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak, and as he pulls himself over the final rock, he is greeted by a band of theologians who've been sitting there for centuries. Now think about that. You know, what is the God of scientists? It's their mind and reasoning, and that's what they have their faith in. But in reality, if you actually look at the firmament like he did, you can actually see that God's behind it all. So what I want to say is simply this. Our creation screams that there is a creator. And it's our responsibility to accept it as individuals and hopefully to be able to look at our creation and share that with other people. You know, earlier on I had read from Psalm 19. Verses 9, 10, and 11 in Psalm 19 go like this. It says, "The fear of the Lord is pure, enduring forever. The ordinances of the Lord are sure and altogether righteous. They are more precious than gold. They are much pure gold. They are sweeter than honey from the comb. By them your servant is warned. In keeping them, there is a great reward." You know, as a beekeeper, I know just having the sweetness of honey is a temporary discomfort whenever you get stung a few times. But the great reward is that you have that sweet honey. The Bible has, I think I've read over 300 different references to honeybees, bees, and honeycomb, so it's quite interesting. And it seems like the honeybee has a special spot in God's heart also. But as I read this passage, it seems like to me, it says one gets a great reward and when he receives it by acknowledging God and following his commandments. Revelation tells us one day there will be new heaven and earth. The wolf will lay down with the lamb. Hopefully, God will allow a few of us to keep bees in heaven. Probably then, they won't have any need for stingers, or won't want to use them at least. So hopefully then, they'll give up their honey voluntarily to any who desire and want it. Now think about it. If this dream's true, I will never have to hear again, "Do you get bit much?" So that's it. I hope as you look, not only at the creation, but you look at simple things like the honeybee, you can see that it's a complex insect that had to have a creator produce it. And that's how sometimes I get to share with the unchurched that there is a God, and hopefully it gets people thinking, and hopefully one day accept. So thank you much for having me talk a little bit, and if you have any questions, we can either answer them here. My daughter, well, she was around in the back. I don't know if she left or not. There she is, or I'll be in the back. We have the honeybee hive over there and a few of the things that we use to do it. So, yeah, to make bees. So I thank you. Any questions? Any thoughts? Yes.
This is something I heard a while back, might be too general, but I heard somebody say evolutionists that have decided this is the steps, this is how it goes over millions of years, choose that rather than something that's actually, without even having God enter in the picture, more scientific than what you're saying, because it is a way for them to say, there's no God, this just happened sporadically with the Big Bang and with everything else, and it probably applies as much there as to anything else. Yeah. Because like you said, a lot of the things you talked about with the bees having the capability of doing, if the brain is as big as a pin, how could they possibly?
And how can they share that knowledge? Because they only last 6 weeks. I mean, they can't share, and it's just exactly that. Instincts are put in the mind of an insect or whatever, because God has placed it there. One of my favorite books is I don't have enough faith as an atheist, because an atheist has to have more faith than I do, because it's easier to point to a supernatural God. Think about it. Even scientists will say there was a point there was nothing, and nothing cannot create something. It's impossible to think that. So there has to be something greater than the sum total of creation, more powerful and have a greater mind than all of creation to be able to do this. So because we have something, because we have stuff, I'm standing on stuff, there had to be something that created that stuff. And like I said, the Big Bang guys will say, yeah, there was a Big Bang, but they can't explain what was there beforehand and why it started. It's just amazing. Yes, Mark?
So let me ask you a question.
Sure.
What does the honey that's actually in the comb taste like compared to what you do and process and then use for resale?
Well,
talks about more sweeter. So is it sweeter? What's the difference?
No, the difference in honey is basically by the varieties of plants that the honeybees forage. For example, my spring honey has more of a peachy aftertaste, and it's a little sweeter because it's higher in fructose. Fructose, tablespoon per tablespoon, is sweeter to the palate than sucrose and glucose. So it actually tastes a little sweeter, but it really, in reality, isn't. In the United States, for example, we have 300 different varieties of floral sources that will actually produce honey. So each one has their own unique characteristics, the flavor, the color, the sweetness, and the ability to granulate or not to granulate. Granulation is a natural process of honey. It actually turns to sugar, and so it makes it stable. But there's one honey, Tupelo honey in the South. It's higher in fructose, so it does not granulate, particularly in the pure state. So that is basically it. Now, beekeepers can change the flavor of honey by overheating it. I get asked all the time, do you pasteurize your honey? Well, pasteurization, as far as I know, Louis Pasteur realized you had to go to 185 degrees to be able to heat stuff up so there's no bacteria in that material. If you do that with a sugar source like honey, you're going to scorch it. So we do heat some of our honey. We heat it to about 135 degrees. The reason we do that, it clarifies better, because when the process of making honey, some air gets whipped into the honey. By heating it to 135 degrees or so, the air bubbles will come out quicker. It's easier to pump. What I do is my process actually goes from extractor through a sump tank, and it automatically pumps it up into a bottling tank. So it's easier to pump into there. It clarifies. It's easier to filter. My sophisticated filter is a double nylon stocking, preferably unused. So it takes all the little bit of debris and some larger pieces of propolis and or pollen, and then it's easier to bottle. But we do raw honey, which has never been heated. But right now, when I have it, the little bit I have left right now, it's granulated. I put it in a wide mouth jar so you can scoop it out. So by overheating it, those unique flavors and floral sources can be easily broken up and destroyed. So you want to know your beekeeper to determine whether or not they're overheating, flash heating it, or whatever. So it's important to know. So, yes?
Psalm 19, verse 1. The heavens declare the glory of God, and the earth shows forth his handiwork.
Yeah. I mentioned that earlier because I mean, and that's the idea of what I'm talking about by God's glory. God, I don't know how to describe God's glory. I don't think it's an attribute, but it's just because of what He's done, it's revealed to us. And by acknowledging that, we're understanding the manifestation of what God's glory is. And that's why I'm trying to tie it into the honeybee, because I recognize that God is behind this creation that I like to have this good relationship with. And to me, again, I call it the fingerprints of God, so that you can just actually look at it and say, hey, yeah, I'm thankful that there is a God. And any other questions? Any other thoughts? Okay, I appreciate it. Thank you. We still have the honeybee thing there. I'll let it up for another couple minutes if you want to look at it. Like we got an observation hive there and some of the tools of my trade. My daughter, if she's still around, she was the 2011 Pennsylvania Honey Queen, and she ended up winning the national title. She was a 2012 American Honey Queen, and so she was able to go out there, unlike us having 15, 20, 30 people that I get to talk to, she actually probably was able to communicate what the bees are about. Unfortunately, not with a Christian viewpoint, but at least a viewpoint of what they are, and the pollination, how necessary pollination in honeybees, and how good the honey is to probably literally hundreds of thousands of people. So she like I said, she actually got to visit the bees on the White House lawn before she gave up her title, and so she was all over. So it was fun. So if you get a chance, you can even talk to her if she comes back up. So I thank you very much, and hopefully in a couple weeks from now, when you want me to talk about miracles. It's a miracle I got through pretty much on time here now. Thank you.